hopefully.
It chimes in when you do that. I can hear a little ding and
Yay! All right. Well, do we want to work on part 2? Or
okay.
Like,
I haven't even started looking at part 2.
that is okay. I've been looking at part 1 going, okay, I'm trying to figure out question 2, and I haven't found it in the textbook yet, so I'm like, what does this?
Question 2?
Yeah.
HA. That was...
Describe the null, but I understand.
Okay. Yeah, I read it in there, and it's when it's not equal to, then it's a two-sided hypothesis or alternative hypothesis. Are you there? I think you're frozen. Okay, are you back?
Let's see. We'll send Sari another one.
Okay. So when it's not equal to, then it's a two-sided hypothesis.
Okay.
And when it's less than or greater than, then it's a one-sided hypothesis. I guess if you think about it like when we look up the p-value or when we go to the applet, and if it's less than, we shade only the left side. If the story, you know, what we're trying to figure out is less than. And so, and then if it's greater than, then we shade only the right side of the applet. And if it's not equal to, then we shade both sides, making it a double tail. That's kind of what they're talking about.
Okay. I think so.
So, whatever.
Like, it's math. Like, we'll get it someday. At least I will.
Yeah. So
Okay.
it talks about that.
Oh, there you are.
Yay.
Yay.
Having issues.
Oh.
I'm here.
Exactly. That's a good thing.
That's right. How is the test, guys?
It wasn't bad.
You thought it wasn't bad?
Yeah, I thought it was okay.
I don't know. I think the timing for me was not good. I made a C on it, so I don't know.
Okay.
Yeah. I don't know.
Yeah.
There were some questions that I was like, what? I don't know. I mean, like I felt like I knew most of it, but I probably just messed up on stupid stuff too. So.
Yeah, you probably overthought some of it.
Yeah.
Because I thought you understood it pretty well. So.
Yeah, I don't know. Just like 3 or 4 questions that I almost just drew a blank with. I just couldn't figure it out. So. Oh well. Anyways, how'd you do, Linda?
What did you over with?
But I did pretty good. I got a 93, so I'm pretty happy with that.
Good. Good. Yeah. Anyways, but yeah, so all right. Did y'all have a chance to go over this lesson, or?
It's a really, really long lesson. I've got about halfway through the lesson, so
It is long. It's I did the first half, but I didn't start on the part we're supposed to do together. So.
Yeah, I haven't done that either.
Yeah.
I'm still working on the first part.
Yeah.
There you go.
Oh, goodness.
The normal.
All right. Okay. Well, what do y'all want to do? What do y'all want?
Let's get it started.
Okay.
Yeah, I've got to make up for what I didn't do already for my other classes. It's like, what? That's too long studying for that test.
Right. Oh, yeah. That's the thing is I didn't actually study for it either. Like I didn't take any time to study for that test, which I should have gone back and reviewed. I think that's where I forgot was some of the stuff from the beginning, and I just kind of drew a blank on a few things. But now now that I kind of get how the tests are going to be, I'm like, okay, now I know like how to study and whatever.
Yeah, I thought for me, I used the review thing, and I just wrote down everything that was important to me on the review, and it worked well for me.
Yeah. How did you? What did you?
They had the summaries.
Did you make an A?
I got a B.
Oh.
Not too bad.
Yeah, that's good. Yeah, I don't know. I think I kind of know the area I messed up on, but I wish when she gives the answers that she would do a little explanation on, you know what I mean? Like, so you can understand why you missed, but.
Yeah. Well, maybe we'll get them soon, because I know I have a friend who just is in the same biostatistic class in my apartment, and she just took it. So I think it's probably soonish that we'll get our answers.
Yeah.
What we got wrong.
Okay. Well, good. All right. Well, let's see. Number 1, the graduate management admission test, GMAT, is used as an admission criterion in many masters of business programs. The scores on GMAT in the past have a mean score of 529. BYU professor feels now that the score has improved within the last couple of years. Determine the null and alternative hypothesis. Okay.
Okay, has improved. Okay, so the null hypothesis, the H. I just read that that's not an O, but it's a 0. So the H0.
Oh,
I
okay.
thought it was an O. It's a
I thought
zero.
it was saying sigma, so I was like really confused.
So the H O or 0,
Mm-hmm.
and then colon mu thing equals. So the mean is 529. So that's the past one. So the future one is saying that the score has improved, so it would be a greater than
For the alternative.
The alternative, HA, greater than 529. Okay. And suppose you got evidence that the null hypothesis should be rejected. However, in reality, the mean score of students taking the exam is still 529. That's something wrong there. What was it, a type 1 or type 2 error committed?
Suppose you got evidence that the null hypothesis should be rejected.
Okay,
However,
so
in reality, the mean score
reject hypothesis, reject.
for taking the exam is 529. That is, if you look at that little chart on the first chart, so type 1 is if you fail to reject a false, like if you fail to reject and it's false, so that's type 1.
Type 1 error, okay.
No, I don't know. No, I don't know. Is it false? Suppose you've got that the null hypothesis should be rejected. However, in reality, the mean score of the student's exam is 529.
So our evidence is wrong. So the reality is the mean is that it is still 529. So the hypothesis is right. We rejected it in error. So that's a type 1 error. Right?
Well, it doesn't say it was rejected. It just says, suppose you got evidence the null hypothesis should.
Okay. Okay. So, so then, according to your evidence, you're going to reject it.
Huh?
So, according to your evidence, you're going to reject it.
However, in reality, the mean score student. Well, then type 2 is rejecting the truth.
Type 2. Fail to reject.
Type 1 is rejecting the truth. type 2 is failing to reject not the truth. So type 1 is rejecting the truth, and then type 2 is failing.
So we rejected the truth. That's what it's saying in this question. We're rejecting the truth. So it's a type 1 error.
Okay. That is so kind of confusing to me. Like,
Yeah, it is.
I hate how they say fail to reject. That is so like, why?
It's a double negative. It's hard to understand.
I'm like, why can't it just be reject? Like, why isn't it reject and
Right.
not reject?
Because in English, if there's a double negative, then it equals a positive, right? Yeah. So if you're saying it's not true or it's not false, you're saying it's true. So the not and false is a double negative. So in English, that means true. So that's why it's confusing in our minds about the failing to reject thing, because it's a double negative and it should make a positive in our minds. Anyway, that's
yeah, it's really
kind of weird.
And if they just fail to reject it, it's still a positive. I don't know. I don't get it.
So.
Okay.
So then the hypothesis stands. If you fail to reject it, the hypothesis stands, because in reality, the mean score is still 529. So.
Okay. I just have to think on that a little more. I don't.
Well, if you read it was either in the chapter or the video. Maybe it was the video. He talks about, like in a court case, you're innocent till you're proven guilty, or that you're not proved innocent, you're just proved not guilty. They don't say you're innocent. They just say you're not guilty because they haven't proved that you're guilty.
Okay.
They don't declare you innocent.
Oh, you could still not guilty, but they're just declaring you not guilty, even though you could be guilty. Oh.
Right. It could still be wrong, but anyway, yeah. Anyway, something like that.
I have to really think about it. It's like I get it, and then I'm like, oh, wait a minute, like it still doesn't make sense. Like it's hard for my brain to accept. Like, why is this right? Okay. All right. C. If the analysis was done at little a symbol.
Alpha.
What? What is it?
Oh, it's alpha.
Oh, yeah.
Alpha.
Yeah, that's right. Alpha equals 0.01 level. What is the probability of committing a type 1 error? Okay. So.
I don't even know what they're talking about. Okay, if the analysis was done, HA level. Okay, so that's 1%. What is the probability of committing a type 1 error? 1%. I don't know. There's a 1% chance it would be a type 1 error. That's what
Makes sense.
That's what it says.
Is that the answer?
Yep. Yeah. 1%. Wait.
Okay.
Trying to read more into that than I guess that it is.
Like some Z-score stuff.
Yeah, it's just what you get in the analysis.
Of the steps, but they're not asking for us to do more than that. So,
yeah.
Whatever. If we wanted to decrease the probability of making a type 2 error would we need to increase or decrease the level of significance?
Okay, I was reading about that level of significance, and I was trying to understand that. So, the level of significance is the number to determine if the p-value is small enough to reject the known hypothesis. The probability of making a type 1 error. Would we increase?
Well, here it says in the textbook, if I'm thinking about it correctly, it says if the alpha value is very small, the probability of committing a type 2 error will be large.
So we would need to increase the, if we wanted to decrease the probability of making a type 2 error.
Increase.
Wait, read that again, Kelsey?
So it's in the textbook, it's right underneath the little diagram of truth, decision, fail to reject hypothesis, anyway. But it says if the alpha value is very small, the probability of committing a type 2 error will be large. So like it says the alpha value is the probability of committing a type 1 error in parentheses. So if we want to decrease the type 2, we decrease the type, or we increase type 1?
Well, if the alpha sign is small, the probability is large. Is that what it's saying?
Yeah. So if alpha is very small, type 2 will be large.
Small.
So
type 2 will be very large. Okay.
Okay, so then if we wanted to decrease the probability of making a type 2 error,
we then increase the level of significance. Okay, so
it would need to be large because
yeah.
then the type 2 would be small.
Right, so you increase it.
Increase.
Okay.
Whew, a lot of deep thinking.
Yeah, it is. I didn't get all the way through the chapter, so it's going to be hard to think.
Yeah.
I was reading it this morning, and I was so tired because I had a busy day yesterday, and that's probably, I think when I took the test, I wasn't like in that mode of like my kids were home, hear them like fighting, and like the doorbell was ringing, the dogs bark. I was like, ah! I was like, when I take the test, it's gonna be in like peace and quiet because I would like look at the clock and be like, oh my gosh, yeah. How long did it take y'all to take it? Did it take y'all?
If I took more time, I probably should have taken more time, but I took it in like 30 to 45 minutes.
Oh wow! Holy cow! Yeah, I took a lot longer than that.
Yeah, I took about an hour and a half. I went through everything again to make sure because when we'd done the other test, I made a couple stupid errors by putting in 2 decimal points and things.
Yeah.
So make sure I didn't do that.
I had to stop. Like I had to literally just stop and go go away and then come back, and so my clock was still running, and I knew I'm like, okay, I have this much time, and whatever. Yay!
Okay, number 2. A study by the National Association of Realtors reported that in 2004 that second home sales accounted for more than a third of residential real estate transactions. According to the report, the average age of a person buying a second home as an investment rental property was 47 years. Okay, so the average age. Assuming the national standard deviation was 5, a real estate agent wants to determine if the average age of those buying investment property in his area is different than the national average. He randomly selects 15 of his clients who purchased an investment property and obtained the data. Okay, design the study. What is the population from which the realtor obtained his data? So it was his clients, I guess. Let's see. He wanted he
randomly selects 15 of his clients.
Okay, so he selects those from all those who were second home buyers. Let's see. So the people buying a second home as an investment rental property. Well, I guess that's okay.
What are y'all putting?
I'm still thinking about it.
Yeah. Is it the mean population? I mean, what kind of population are we talking, like a sample population or a regular?
I don't think it matters. I think it's asking for like whether it was statistical or strategical or a sample or a simple sampling. I think it's asking for that and then asking what the question that he's looking for is what they're asking for.
Okay. So what is their
Oh,
question?
and what is the population? Yeah.
Okay.
That's the population.
The population is
Yeah.
the people buying a second home, because he's going to look at not only his clients but the other people, because he's got the average age of 47 years.
Mm-hmm.
So 47 is the mean.
Is it the people? Wait, which kind of people? Are we talking about like second home sale people?
Yes.
Mm-hmm.
The people who bought a second home.
Second home.
And then the mean was 47 and the standard deviation is 5. Let's see. So the question he's asking is, he wants to determine if the average age of those buying real estate property in his area is different. So he's not saying if it's greater or less, but just different. So not equals, right?
Mm-hmm.
So the hypothesis is then, I guess it's not asking that, but the hypothesis is that it's 47 years, and the HA, his alternative, is not 47 years. He's not saying whether it's old, if they're greater or less, right? It's different.
What question are we on? Did we finish?
I'm on part A still.
That's what I was.
I know.
Okay.
Last
What is
question.
the population from which the realtor attains his data? We're putting second home buyers. How did he sample his population?
I was thinking, is it simple?
It's the simple random selection.
Simple random from his own clients.
Yeah, the SRS.
Yes.
Whatever it is.
Mm-hmm. And what is the research question? It's asking
that if his his clients are different than the national average. So it's not asking greater or less, but if it's different.
Okay.
So
different. So it'd be just the HO:U equals, or
U equals 47, because that's the average, and then his hypothesis, HA, is not equal to.
Not. Oh yeah. Not equal to
47. That the mean is not equal to 47.
We got a different bus driver for the.
Okay.
So. Okay.
Okay.
Select the data. Name at least one way the realtor could have randomly selected his sample. He could use the random generator on the computer.
Mm-hmm.
He could cut up all these numbers and put them in a bowl and fish them out.
Yeah. Generated.
You could have also couldn't you have just waited for those that were looking for a second home just to walk in?
Mm-hmm.
As they were.
Well,
Maybe you guys are.
He randomly selects 15 of his clients. But then that would be more of a convenience sample, and they said that's not as accurate. So he can't just say the next 15 that walk in.
So
Okay.
we're saying he could have done a generated sample of all the people he's used over the years that bought a second home.
Right.
And
Sure.
yeah, I mean, he could have done like a cut them up and put them all in a. Well, that's the same kind of thing, I guess. And had someone draw them out of a hat or whatever.
Right. That would be random.
Yeah.
Describe it again.
Yeah, describe the data, graph the data on a histogram. Sketch the histogram below or cut and paste your electronic copy in a short paragraph. Describe the data by using 5 descriptive statistics. Okay.
I don't want to open that.
Yeah. Do you have to? Let's see. Okay.
So true. Okay.
File new. I've already got this open, so
Lucky.
so I'll just
I have to
stick
open
them
up
in.
the laptop.
27, 35, 49, 55, 58, 50, 51, 45, 46.
All right. So what are we entering in? Are y'all just entering? How are you doing it?
I'm just putting it in.
Yeah.
In
Like those numbers, the 27, 49?
Yeah, just
Yeah.
putting those down in one row and then graphing
one
them.
column. One column.
Just one
Yeah.
column?
Oh, yeah.
Okay. Not any, like you're not going across, you're just going down?
Yeah, because that way it's easy. Well, either way. I don't know if it really matter, honestly.
I think it's like just makes it do it like horizontal or vertical. I don't know. I was fooling with that the other day on the test on one of the questions. Did y'all use this on your test at all?
The SBS, we had to use it for some of the data.
Yeah.
One thing.
Yeah. I was trying to figure out something else with it on the test at one point, and then it just, I don't think I was doing it right.
Okay. How do we get rid of those 2 zeros? I forgot. Do you guys remember how to do that? Let's see.
I don't know.
You don't remember?
I have
Well,
no idea.
I'll
what
just
is
ignore the
it?
zeros. I know we did that once. Data. Okay, so I will collect this and analyze descriptive values. Explore. Do we need percentages? No, I need a QQ pop-up. Continue. Plot. Oh, okay, that should get it. Okay, give me QQ plot too. All right, let's see if I did this right. I got a mean of 46.733. Mean of 46.733. Standard deviation.
Are we just supposed to put 5, like mean? What all are you guys putting down? Just
Describe the data. Make a graph. One minute. Graph. Okay. And let's see. Okay, there's the QQ plot. The requirements. Okay, we're supposed to
make a histogram. That's what I did. So
Yeah.
histogram. Mine looks like it's left skewed. Is yours?
Okay. Well, I have a QQ plot. First, I haven't made a histogram yet.
Did you do a histogram, Kelsey?
I'm trying to get it. I had it set up so it was in a in a row instead of a column, but it was going to be a big hassle.
Hmm.
So I started over.
Oh, okay. Yeah.
Okay. So.
So the minimum, are we going to just do the 5?
Oh no, I didn't do that. That's a box plot. Okay, let me try that. Let me try something else. Okay, where'd my data go? Oh, there it is. Okay. Okay, let me find a QQ plot. Oh, there it is. Okay.
Okay. So I have the mean as 46.73 and the first quartile as 38. Second as
So, what did you say the mean was?
46.733.
Oh, right. Okay.
Yeah. And the first quartile I had 38. And I did the percentages on the descriptive.
Okay. So since there's only 15, the sample is only in size 15. Less than 30, we'll have to decide whether it's a normal plot. So I did a QQ plot. And
normally I don't do that. Normally
I don't know, I guess it's normal. I guess so. It's a little bit off on one side, but maybe not too much. It's not too awfully. Do you guys have a QQ plot?
Yeah.
Let's see.
What's going on?
So we'll say, I guess, that it's normal.
I thought it was kind of less skewed.
Yeah, that's what I thought too.
Oh.
If you do it says to do a histogram and not a QQ plot.
Okay.
Yeah. The history, I mean.
Well, okay. That one,
yeah.
Well, it could be. It's hard to tell. For me, it's hard to tell with that QQ plot. Okay, I'm going to say that. Let's do a histogram.
I mean, I guess you could do it with the Q and Q plot just because it depends. Like if you were to look at it how we do in the textbook, how it's horizontal instead of words are escaping me, but the other way. You could potentially still tell.
So yeah, it's very left skewed.
Mhm.
Yeah.
Okay.
So maybe we can't use the other thing. Well, I don't know. If it's left skewed and there's only a sample of 15, then
it would be unusual.
Then we can't analyze it with the applet stuff. It's not normally distributed.
Right.
I don't know. It's okay. Okay, to the histogram. Make inference. say, check the level of significance. I don't know how to do that. I don't know how to do that. Check the significance. All right. So I would say it was a two-tailed test. This is on the one part. Two-tailed test because when it's not equal to, then it's a two-tailed test.
How do you tell if it's a two-tailed test or not?
Because it's not equal to the hypothesis. The alternate hypothesis is not equal to 47. If it was, I wrote that down. I did get to that part. If it is less than, if it's less than, then it's a left-tailed because you highlight the left part of your applet, right? That's how I'm thinking about it. And if it's right-tailed, then you highlight the right of the applet, meaning it's greater than. It's greater than the mean, right?
Yeah.
Greater than the mean, or less than the mean. So that means it's left-tailed or right-tailed. But if it's not equal to the mean, then the book says it's two-tailed. So
If it's not equal to the mean, it's two-tailed?
Right. Then that's what this question was. It was not equal to, so it's two-tailed. But I have no idea what the level of significance would be. Okay, let's.
What do we get as the mean? Is the mean 47 or?
Yeah, or 46.7.
Oh, right. So how did we figure that it wasn't equal to the mean? I never got that.
Well, we're not there yet. That's just the alternate hypothesis.
Oh, that's the alternate. Okay. State the null and alternate. Okay, but the null is that it is greater than 47?
No, that was the question says. I guess I talked about that earlier, and it's supposed to be this question here, but he wants to know that if he wants to determine if the average age of those buying in his area is different than the national average. So he wants to know if it's not equal to 47. So he's saying if it's different.
Okay, and then
he doesn't want to know if the age is more or less. He just wants to know if it's different. So
the alternate would be that it is equal to 47.
No, that's the alternate. Oh,
yeah.
The HO colon the hypothesis, the null hypothesis is the mean equals 47. HO.
Oh.
Okay, the null is HO equals 47, and the alternate is HA doesn't equal.
Doesn't equal. The mean does not equal 47.
Okay. And a two-tailed is when it's not equal to the mean?
Right. I don't quite know if that's the way they call it, but so anyway.
But how would we know if it's two-tailed or not if we don't know it? We don't know what it is yet.
Well, because it's not equal to the.
Yeah.
It's just describing the test. It's just describing the test. So if it was less than, if he wants to know if the age of his people are less than 47, then when we get to the applet, we would highlight just the left side because it would be less than the mean. And so then it would be a left-tailed test. And if we wanted to know if his clients were over the age of 47, we would highlight just the right tail. And that would be a right-tailed test.
And that those would be Those would be one-tailed tests?
So yeah, it would be either one tail. It would be the right or the left.
Okay.
Yeah.
Because we're looking for greater than or less than, right?
All right. So right or
Yeah.
okay. So right or left-tailed tests are one-tailed tests, and two-tailed tests are if they are not equal to the mean or equal to the mean. Either way.
Well, you can't put. There's only 3 alternatives for the alternate because the hypothesis, the null hypothesis, is equal to the mean. That's the mean. That's 47. And so it has to be something different than that. So it's either greater than, less than, or not equal to.
Okay. Okay. I'm starting. It's starting to come together. It's yeah. All right.
That's about where I got in the reading. So I'm about done.
Yeah.
Yeah.
Yeah. In the reading, it's about the third way through the website. So.
Okay.
That's yeah. It makes sense looking at it. It's just thinking about it. It's like
yeah.
yeah.
That's how I have to really like just sit down and have time to think about it all. Like let it soak in.
Yep.
Like if you hear it once, it's like what? Okay.
So and then the third part 3 says let the level of significance be A equals 0.05. Okay, so 5% is the level of significance to determine if the p-value is small enough. Okay, okay. So if it's less, okay, so it's 5%. That's what we've normally seen. So, okay.
Which problem are you guys on? Are you on?
I was just talking about. Let's see. We're making inferences after we said that was a left skewed histogram that we made. So now we're looking at our data and making inferences.
Okay. So we're on compute the test statistic or state the null. Oh, you know what? That when I printed it off. Okay.
Okay. Yeah. Compute the test statistics. That's where I'm at right now.
My it's cut me off again. Like the. Can y'all hear me? Yeah. Like the paper. It doesn't show everything again, so I'm gonna have to go in here. Yeah, I can't see everything.
I'll read number 4 then. It says, compute the test statistic. What is the formula to be used? Recall our test statistics will be a z-score. Okay. After writing down the general formula, input the numbers you will use. So you'll finally use Excel or calculator to compute your test. So we're going to find the z-score then of this. So
I started asking questions to figure out why.
So the Z, okay. Oh, yeah. The mean.
What question are we on?
I'm looking at D4, where we're computing the Z-score.
Okay.
Well, the mean of.
Yeah, it doesn't have it on mine. I don't have any of question 4. Like I just pulled it up again, so.
It's so long.
There
we go.
So you can try do the Z, which was the Z-score. Which
Wait, is this? Oh, okay. It's Roman numeral.
the mean that we got when we put that in was 46.733. Let me see if I did this. Minus the mean that is 47 over.
Oh, I forgot to look at
this.
Did y'all get the standard deviation on the graph? Because I forgot to get that.
Yeah, the standard deviation is 8.82745 is how far I went. So then the standard deviation is 2.745. Okay. 8.8. equals negative 0.117.
Did you guys get a z-score of 0.1176 or something like that?
I did, but I don't know if that's right. Huh. Mm. 0.827. 4527. Yeah, I got that, but it says it's wrong. Let me see.
Maybe we wrote down the wrong standard deviation, or
Yeah, because in 2, in the information it gives us a standard deviation.
oh, it does.
Yeah, the
Oh,
national
it says
standard
it's
deviation.
5.
Oh, I
Yeah.
was using the wrong one. I
Yeah.
was using the wrong one. That's my problem. Okay.
Okay.
Okay. Thank you, Kelsey.
You're welcome.
It's supposed to be 5 and not.
Yeah.
Okay.
Okay.
Okay, that's my problem. 5 divided by 5.
So did you guys get 0.207?
A negative? Is it a negative? I got a negative 0.2068. So yeah, it's a negative. Yeah. Why did I get a negative? Let me do it again.
Wait, so what did you guys get?
I got a negative.
I
Yeah.
got a negative 2.
Yeah, I
You
did.
got
too.
negative 2? Oh,
Yeah.
okay.
A negative 0.054.
I
Mm,
didn't get that.
I didn't either. 267.
I used the mean from our from the SPSS,
Uh-huh.
and then I subtracted the 47 years.
Uh-huh.
Right.
Divided by the 5.
What did you get for your mean, Kelsey? Because
the mean, I used what it gave us, or when we did the histogram.
yeah, I mean, what was the number? What is
It's
it?
46.73.
Okay. Yeah. Okay.
Yeah. So I just put what I said into the calculator, subtracted 47.
That's what we
That's
did, and I got 0.267.
Oh.
That's 46.733 minus 47.
Oh, I think I need to do the sample population.
Yeah.
Right. It's divided by the square root of 15.
Yeah.
Yeah, there you go. That's why I got something different. You guys are probably right.
Okay, so it's 0.2. I rounded up, so 0.207. Is that what you got, Linda?
A negative, yeah.
Yeah,
I got a
negative.
negative.
Yeah, negative.
Okay, I'm doing it again just to make sure. 47 equals divided by it's a negative 2.2068 or 7. You could be, okay, it's 210.
Okay. This time I did it and I got negative 0.209.
09?
We got negative 0.2068.
It's probably just the rounding of the calculator because I made sure I just didn't shorten anything.
Oh.
Because I have a graphing calculator.
Oh.
Okay, so if we put this in our
applet.
Okay, let's see. And it's a two-tailed, so I think we're supposed to highlight both sides. Okay? So 0.2068. Oh, that's a narrow little thing. So then I get 0.836 or 83.6%. Did it round that? Try to transfer.
So What's the area you guys got?
I got 0.8360.
Okay, I at least got the 8.3. I just have 8.344.
Oh.
Yeah, I got 0.836 also.
Yeah. I wonder what's the answer by the book or the answer sheet say?
0.209. Oh, the answer says it gives Kelsey's score 0.2091. Is that what you got?
Yeah,
Kelsey?
yeah, that's what I got for
Okay.
my Z-score.
Okay, tell me exactly how you did the Z-score. Give me all the numbers.
Okay, I used the, I have to go back. Hold on.
Yeah, give me the numbers. Is it 46.733?
Yeah, I used 46.73, and then I
And you stopped it at that point? You didn't use
yeah, I
any
just
more
used,
threes?
yeah, because,
Okay.
yeah.
Mm-hmm.
Anyway, so I
Okay.
used that.
Because I put an extra 3 on the end because it goes 3, 3, 3,
Yeah.
3, you know.
Mm-hmm.
Yeah, so then as I was calculating, I made sure that I didn't round anything. I kept it all the same.
Mm. I did that too. I'm not using a graphing calculator. Maybe I need to switch over.
Yeah.
Well,
You could do it without a graphing calculator. It's just there'd be a lot of button pushing.
yeah, that's what I'm doing.
There's one calculator, graphing calculator, like if you use the Texas Instruments one, you
Mm-hmm.
go the next step down where it's just one line instead of a big screen. You can potentially still do the same stuff I do. It's just
Okay.
tiny screen.
So, yeah. Once I knocked off that extra 300ths, then I got your negative 0.209.
Yeah.
But I don't know. Are we supposed to knock it off to the? I don't know. I don't always. I usually take it out one more space.
Yeah, I don't either usually, but anyways.
Okay, so if I put that Z-score in there, 0.209, and I get the 8344.
Yep.
0.8344. It's just a rounding thing from what I got.
Yeah.
It's
Because
just
the
that.
83 was the same.
Yeah, 83%. But sometimes that can make a point difference.
It can, and I'm wondering if like I've missed stuff on tests just because of that. Like just being a point off. I don't know.
Yeah.
Okay, so that's the value, and the p-value. So that would be Roman numeral 5.
Okay.
Compute the p-value to the level of significance. Now, how do we do that? They said the level of significance was 0.05 or 5%, right?
Mm-hmm.
0.05.
So is it greater? So our p-value is 0.8344. Is it greater than 0.05 or less? It's greater, right? It's 0.8344.
Yeah.
So that's how we're supposed to compare.
Right, because if it was extreme, it would be way out to the edges. So
right. So it's
it would be past 2. So it would be past 2 standard deviations. It would be out that way. So it's not.
Right. So let's see. Compute this test. What is the formula?
So we fail to reject the null.
Yep.
Then it stands that the average age of people buying second homes is 47, right? Is that it? So, or we just, something like that. We've got done.
Wait, state your conclusions. You're just going to put...
Well, I was just going to put, so, we failed to reject the null, right?
Mm-hmm.
And then, reject null. And so that the null hypothesis stands that the average age of those buying second homes is 47.
Right.
Good job.
Okay.
We have insufficient evidence to conclude that the mean age of people buying a second home is different in this area. I guess, yeah, we don't, I guess I said it wrong. We can't actually say that that's true. We have to say that it's not false. So,
Wait. So we failed.
anyway.
We
So
failed
we
to reject.
failed to reject them. Okay, so that's saying, yeah, we don't say it's true. We're saying it's not false. Or we're saying it's
True. A double true. A double.
we haven't failed to reject it.
I hate all the way this is.
I know. I hate the way it says it too.
Oh, I think I'm gonna struggle on this test, guys. I don't think I'm getting any of this. I don't know. Maybe I'm just tired. I think I need to take a nap.
Amen.
I know. My
So,
brain.
What action, if any, do you suggest the realtor to take based on the statistical conclusions? Well, he could keep targeting middle-aged people in about 47 years old.
Or just be okay with his conclusion. Be okay with what they found. What action? Yeah.
Age 47. So, all right, let's see what we've got here for the next part. See what more damage we can do.
All right.
Okay. Group
Brace for
meeting.
impact.
Brace for impact. Okay, loading. Okay, I'll press start.
Okay. It doesn't look too bad so far.
A hypothesis test consists of two hypotheses, the null hypothesis and the alternate hypothesis. Which one represents the status quo? The null. Right?
Yay! We got one. Yeah. That one was easy.
Which hypothesis involves equality or whatever?
Oh well, we got one.
Well,
I think it's. Well,
I wrote it down somewhere. Let me go back.
Let me look.
my gut reaction was the null hypothesis, but I don't think that's true.
Let's look. Equality. It should be early in.
Yeah, equal to the difference of the norm or status quo. Yep.
Okay, notice that the null hypothesis is expressed in a statement involving equality. Okay, there we go. Okay, the null hypothesis again. Yay!
Yay! The p-value is the probability of obtaining a sample statistic at least as extreme as the one that was actually observed. Use the information to answer question 5. When computing this probability, which hypothesis do you assume to be true? When computing
The null hypothesis.
Yeah. Well, if it's small, wait. Okay. If it's small, like if the p-value is.
It didn't say it. Oh, yeah. But which hypothesis? You always assume the null hypothesis is true.
Okay. The p-value.
Because you
P-value
use that.
is the probability of obtaining the sample statistic at least as an extreme.
That's just giving the definition of the p-value. So we can even ignore that.
Oh, okay.
I would.
Oh,
It's confusing.
Yeah. Okay,
When computing this probability, which hypothesis do you assume to be true? You always assume the null hypothesis is true.
Yeah.
When you're trying to prove it false.
Right.
So you always assume it's true.
The alternate is always trying to disagree with you.
Right.
Yeah.
Okay.
Okay.
So,
Suppose that the null hypothesis is so HO mean equals 10. which of the following represents the alternate hypothesis of a two-tailed test? Okay, I think I know this. Remember, the two-tailed test was not equal. So the HA would be the mean that is not equal to 10, right? That would be the two-tailed test. Okay. And which of the following represents the alternate hypothesis is a left-tailed test? So that's less than. A left-tailed is less than.
The mean is less than, or 10 is less than?
So, pardon?
The mean or the 10 being less?
Yeah, which one is that? The mean or the 10?
Okay, it's the mean would be less than 10. Yeah,
Okay.
I can tell you it's the first one because it will be different on you. Like it. So
10 is greater than
that's
the mean.
a left. I mean, the arrow is pointing left. How about that?
Yeah.
Is that right? Am I getting the right one?
Yeah, the trying to eat the number 10.
Yes.
10 is greater.
The Pac-Man. And then the next one is right-tailed.
Which is the opposite.
So it's the arrow's pointing right, right? Am I thinking right on that?
Yep. So this time it's trying to eat the U because it's bigger than the 10.
Okay. But yeah, okay. All right, so far so good. The outcome of a hypothesis test is determined
Can I ask?
by
Okay, can I ask something? If we were looking at the applet on that, would it be for 7? Would it be on the applet? Would it be on the left?
Yeah.
The left.
Yeah. Mm-hmm.
And
The
then
left tail, meaning you highlight the left side of the applet.
okay, and then on the 8, it would be on the right.
Right.
Okay. Just trying to put this all together.
You're good. You're good.
Okay. The outcome of a hypothesis test is determined by comparing the p-value to the significance of A. Okay. Use this information 9 and 10, or we could just ignore it. Which relationship would result in failing to reject the null hypothesis? Okay. Is by comparing the p-value. So we just did that. We rejected the null hypothesis because it was a p-value.
It was equal. It was.
No, it was equal.
I mean, it was more than the.
It was greater than. Okay. When we did this, the 0.8344 was greater than 0.05, which was the A level. So the p-value is greater than A. Right? What do you think? P-value.
Didn't we just answer that for one of our questions on our sheet where we wrote down?
Yeah. That was item number Roman numeral 6. That's what I'm looking at right now. So, because it said the p-value is greater than the level of significance. So we failed to reject the null. What relationship would result in failing to reject the null hypothesis when the p-value is greater than A? Right? It's failing to reject. Yes. I think that's right.
That's what I'm edging towards.
And so the next one would be opposite. When A is greater than the p-value, then we reject the null hypothesis. Right?
Yeah.
So if we're looking at the applet, then the percentages would be way out there, like, way past 2. Because 2 is where the 5% is, right?
Yeah.
The 2, because that's 95% of the data. So beyond 2, when the tails are beyond 2, then that's when we reject it. So it would be So
Okay,
that's,
so
that's number 10.
9 is what again, though? P is...
P is greater than A. We fail to reject, just like in the sample we did.
Mhm. Okay. And then
Then 10 is
is
the
P
opposite.
is less than A, and that would be the outlier, like the way far out of the applet, like the
Right.
-2 or
It'd be past
2.
2.
Yeah,
It would
like
be,
3 or 4.
it would, yeah, it'd be past, anything past that 2 point on the applet.
Okay, I have a question, because on the test, one of the z-scores I got, or not z-scores, one of the top of the, when I put in my z-score, I got like a really high number, like 4 point something to the e to the -4. If we get that, what are we supposed to put as the percent at the top? Do you know what I mean? Like if it's really high like that? Do you remember?
Well, I don't think we had any, that might have been one you missed. I'm
That
sorry.
probably was. But if we do, what are you supposed to put for that?
Well, this chapter talks about that. This
Oh.
chapter says how to annotate that when it's,
Okay.
because when it has the little e there, and
Mhm.
then you have to put it up at the top as like a negative. Anyway, it tells in this chapter how to annotate that.
Yeah, how to do scientific notation.
Yeah.
What did you say, Kelsey?
Oh, it's how to do scientific notation.
Oh, it's been so many years since I did that. Like I totally forgot. So is it like you move the decimal so many places? I can't remember. Is that?
Yeah,
Well,
so if it's a positive number, you move it to the left. Like if it's such a big number, you have to move it to the left. I think I just did it backwards.
So if it says like E, it's like, say it's like 4.005 E to the -5th.
Yeah,
power,
you would
whatever.
move the decimals to the left because it's negative.
Okay, like 5 places if it says -5.
Yeah. If it said
Okay.
-5, over to the left 5 places. If it's
Okay.
a positive number, that means it's a really big number and you move it to the right.
Okay.
There we
what
go.
I thought.
I hope we don't have to do that. My calculator won't do that. My brain won't do that either.
Yeah.
Okay, so, let's see. 11, an insurance company is reviewing its current policy rates. When originally setting the rates, they believed that the average claim amount was $1,500. They are concerned that the true mean is actually higher than this. Okay, so they think it's higher. Use this information for question 11 through 12. Okay, which of the following would be the appropriate alternate hypothesis?
That it's not, let's see, that it's not higher.
Okay,
So would it be the
they
one-
are concerned that the true mean is actually higher. So the HA, the mean is
Yeah,
greater than,
so 1,500.
great, okay, so the average claim would be greater than 1,500.
Yeah.
Okay?
Okay. Wait, so that the average claim amount is greater. Okay.
They are concerned that the true mean is actually higher than this. Okay. Which of the following would be appropriate null hypothesis on that?
Because
The
they
average
believe
claim
it.
is equal to
Right.
1,500. Okay.
Hmm.
The insurance company selects 40 claims and calculates a sample mean of 1,650. The insurance company assumes the distribution of sample mean is normal. Is this a good assumption? Sure, it's over 30.
Yep.
Okay. What theorem or law justifies your answer to the previous question? There we go again.
No!
No! The central limit theorem?
Well, let's see. I think it might be the law, isn't it? If it's
It's the central limit theorem because it says if it's over 30, then it'll be close enough. Because it says nothing about whether it's normally distributed or not. And it
Yeah.
says nothing about the U and the mean and the sample mean or the being close together, or, you know, whatever. However they want to call that.
Okay.
Oh.
So the law of not large numbers, that's if it's the, I don't know. I always get confused on
Okay. Well, the following is a test statistic as defined in this lesson. Huh. Test statistic. Okay, let me see. I think it's the X with the line on top. I don't know. Wait a second. A test statistic.
Yeah.
What do you think?
I have to look it up too. But I'm thinking you're right just because it would make sense. But, maybe it wouldn't.
I think, though, when I was listening to the guy this morning, I think it's the Z.
Yeah.
I don't know. Let me look.
Because we use the X with the line over it a lot so
He
far.
said something like, when I was listening to the guy, just remember, I thought he said, we are not going to use the X with the line over it, blah, blah. I don't know. Like, he said it's not going to be used in this for the same.
We will test this.
Yeah. It doesn't have a lot.
I don't know.
Oh.
Did you find it?
I think it's Z.
That's what I was thinking. I mean,
in 4.3.1, it says the p-value is the probability of obtaining a test statistic in parentheses, such as Z.
Oh, very good. I'll go with that.
So
I like that answer.
Yeah.
okay.
All
No.
right. Okay.
What?
Yeah,
Okay,
because
yeah, I found more evidence.
if you're testing for the statistic, you're trying to solve for the little, A thing,
Right. The Z, right.
the Z score, the alpha, whatever. I don't know.
Yeah.
The N is your sample means.
Mm-hmm.
Okay, I like
It's
it.
the S that's a mystery.
Yeah.
The S. This is okay. Next. The historical mean of sales receipt at a grocery store is $150 with a standard deviation of 40. The store manager suspects that the average has decreased. He sets up a hypothesis to test with the following hypothesis. Okay, so it's decreased, so you got the less than 150 with it. Alternate, okay. She will use the level of significance as A equals 5%. She then takes a sample random of 36 sales receipts from her store and computes 144. Okay, what is the Z-score associated with this test? All right. Let's see. All right. So
144 150.
we got a standard deviation with a mean of 150, a standard deviation of 40. And 36.
I will wait to see what you guys get.
Okay, give me a minute.
Yep.
Standard deviation of 40. Okay, 6.66. And let's see, 1.4 minus 150.
Did you guys get negative 8.99?
No.
No. Okay. What
But I
is
got a 0.9 that's negative.
Oh, well, if you round it, yeah.
It just gave it straight to me though.
0.9.
0.9.
Okay. Yeah, well, yeah, if you round it. It's
Yeah.
0.8999. You just need to round it. That's
But you got negative, Kelsey?
Yeah, negative 0.9. That's all I have. I don't even have things to round. It's just 0.9 for me.
Okay, it's 0.9.
Okay.
0.9.
Are we putting negative in there?
I forgot.
Oh, but yeah.
I don't think
Okay, it's less than.
Does it matter?
I don't
Well,
think
yeah, because it's going to be left-tailed. That's what they're saying.
Oh, true.
This is a left-tailed, so it's the negative number. You're going to have a negative 0.0.
I wonder if it really does matter if you just click on the left. Like, I wonder for this answer if we actually have to put a negative. I don't know. Like, if we're doing it in the applet, you just click on the left side and I don't know.
Well, we'll see.
Yeah. And we'll learn. Okay. 17.
Okay.
What is the
p-value?
Have we? I just have a question. Have we ever put a negative in for that? On anything?
On the test, I think I didn't with some of them. And maybe that's why I got a B, but
Okay.
I don't know.
Okay. Okay. What is the p-value associated with the z-score from the previous? So we need to go to the applet.
Okay. Let me review something here. This is going to be a left-tailed. So we highlight only the left side. So it would be 0.184.
Yeah.
So what is the p-value? So it's round to 3 decimal places. So
0.184?
0.184. Okay, yep. What reference would you make about the null hypothesis for this problem? Okay, it's not past the 2, which is the 5%, so I would not reject it. I would not reject it, right?
Yeah,
fail to reject.
Okay.
Okay.
And we're almost done. 2 more. It's a long day doing math for me today.
I know. There are 2 types of errors that can be made when performing a hypothesis test. Which one involves rejecting the null hypothesis when the null hypothesis is true?
Okay, let me look.
Wait.
Okay.
Type 2. Wait, no.
There are 2 types of errors.
I think
Which one involves rejecting?
one.
It's type 1. That
was the question we had in our thing. Yeah. We rejected the null hypothesis when it was really true, and so it was a type 1. Yeah. Researchers decided that instead of using a level of significance of 5%, you would use 1%. Which of the following will be true? Oh.
Wait, was that 19? Oh, no, you were 20. Never mind. The probability of a type 1 error will increase.
Well, with a type 1 being small, type 2 would increase. And alpha is type 1. With him shrinking it or larger.
Oh, wait. So if it's okay, so it's asking if it decreases, what's going to happen?
Yeah, I'm thinking type 2 will increase, personally.
Didn't we do, what wasn't one of the questions something?
Yeah, it talked about it. Where did I find it? If the A value is very small, the probability of committing a type 2 error will be large. Conversely, if A is allowed to be very large, then the probability of committing a type 2 error will be very small.
But this is making A smaller.
Yeah, so if it's smaller, that means our type 2 will be larger. So our type 2 will increase.
Okay, I'll go with that. I like that.
All right.
So wait, which one are we putting? The probability that type 2
Two will
error increase.
Yeah.
Okay. If A equals 5%, compute the probability of committing a type 1 error.
Isn't that 5%?
5%.
Isn't that what we did on the one of those
Yeah.
questions?
Compute the probability of a type 1 error that you will get, that you will reject.
Yeah, where did we do that? Didn't we just do that somewhere? Like it was like asking 1% and we put 1%. Or yeah, if the analysis was done at what is the probability of committing type 1 error? What is
1% chance.
Yeah, so 5%. Do we put 5% or do we just how do we write that?
Put it
Yeah, I
there
have no
somewhere.
idea.
I don't know. That's what I got that wrong last time because I did it wrong. Because it doesn't have a percent sign behind this little box. So
I guess we could put percent.
0.05. I'm gonna.
I'll put in 5% with the symbol.
Okay, you try
That sounds so fun.
that.
Or it won't let me.
It won't let you. You can't put it in.
You can put in the number, but you can't put in the symbol.
Did
So
we
then you have to.
did we check, Linda, to see if that was the right answer for that?
Yes, that was right.
It
that
was
the right answer.
Okay, maybe we should just put 5. Should we all just put 5?
Yeah.
What is the 5? Or 0.05? Or 5? What do you think?
Well, with the homework, it had it as how it is here. Was it a 5? Or
Oh, okay. So you're
percent?
thinking it's just 5. Okay.
It would be weird to put the same thing, like 0.05, because that's what it has.
Yeah.
Well, yeah.
And it's not like it's 100th or
Okay.
500th of a percent.
All right.
I don't know. All right, I'll submit it first.
Okay.
All right, here we go.
Okay, take turns, huh?
Yay, let's see. We got a 95, so let's see what
Oh, that's good, because there's 21 questions.
Okay, let's see. Oh, we missed the last one.
Oh.
Oh, well, I don't know. That's weird.
When you just put 5?
Yeah, I just put 5. Did you guys want to try to put something else? Go ahead. Like, see.
I'll try the 0.5.
Okay.
That's how it's written.
0.05? Yeah.
Well, yeah. Here we go. What's gonna happen? It's right that way. That's weird.
Oh my gosh, that is so weird.
Yeah, that is weird.
Pretty nuts.
Did she
Well,
specify at the top to not? Did we not read something where it says? I don't know.
you can email her and she'll correct that for you. She corrected those two where that one I put 2 decimals in.
Oh yeah.
Because when I talked to her and then she said, well, email me those questions, and I just did, and she gave me the score.
Yeah.
Yay!
Okay.
Wow, that was a lot of work. That was a lot of questions.
I'm gonna have to like really look over this again this weekend because I'm feeling really lost in this material right now.
Yeah. But at least we only have to do chapter 9 homework.
Yeah.
Well, because we've already done our test, and that was half enough.
Mm-hmm. And I didn't see anything for submitting what we recorded last time, so.
Oh yeah.
I don't know if he says something's wrong and you see something come up as negative. I'll just email her.
Do you
And be like,
Kelsey, do you think that this like our final exam will be comprehensive of everything, or is it just going to be like the last test of what we're going over?
From what I've heard from others who have taken this class, it might be a presentation or like a PowerPoint, like a group project.
Yeah.
Because I know coming in the future, we have to present an idea or something like that we could use with biostatistics.
Yeah, I see that as the last thing over. After week 12, then it says course conclusion, and then it says group project.
Okay.
It says that's the last thing, so looks like that's about right.
Has your friend said it was hard, or was it okay project thing?
Pretty okay. I think because it's all up to us on what we do it on.
Oh.
We just have to go out and find the data.
Oh.
So.
Okay.
Can we do an observational study? If we do an observational study, that would be easy.
I'm good with that. But yeah, I think it can be anything.
Can I observe my children? Yes, every day.
Notice how many times they hit each other within 2 hours or something.
All right. Well, good luck. You guys enjoy your weekend.
Yeah, you too.
Okay.
See you on Monday.
Okay. Bye.